To the cloud. So the composition of functions, this came out of a textbook a long time ago, following one function with another. It's kind of a weird way to think of it, but it's really, I mean, if you want a good working definition, it's evaluating one function by plugging in another. So, or substituting, you know, if you want to be all fancy about it, by plugging in another function. All right. The different forms of notation can be a little jarring. I mean, you see all this stuff here, you're like, wow, geez, this is brutal to look at, right? But it's really not that bad once you understand what on earth it's asking you to do. Okay, so for the first part, it says f parentheses g parentheses x, right? That's read as f of g of x, right? F of g of x. What it's telling us to do is replace all x's in f of x with g of x. So replace all x's in f of x with g of x. So what I'll do is I'll write f of x first. What I'm going to do now is what I just wrote, replace all those x's with g of x, literally. So every x in this function, I'm going to replace with g of x. All right. So it would become, instead of f of x equals x plus 5, I'm replacing all of those x's with a g of x. A little crazy with the parentheses, but that's the idea. Every x got replaced with just the notation g of x. All right, now we can go the additional step by saying, oh, wait a minute, I know what g of x is equal to. All right, g of x is equal to 4x. They told us right here. So since g of x is equal to 4x, we can replace each g of x with 4x. All right. So into that expression, I would then write f of, on the left-hand side, I could leave it as g of x, but I could also write it as f of 4x is equal to 4x instead of the g of x plus 5. All right. But the left-hand side, I could go either way with that, because that 4x, once you've established the equality, once you've established that two things are equivalent to one another, they become interchangeable. All right. So if I told you that there was another teacher out there that taught exactly like me, you know, like right down to the forms of technology that I use, you know, like I'm vouching for this person. I'm like, they're just like me. You'll either love them or hate them. Just you'll feel the same way about them that you feel about me. And then if I were to follow that up by saying, by the way, I'm going to be absent next week. This person is going to teach the class for me instead. In your mind, you should be thinking, okay, it's an apples to apples transition. This guy is saying that the substitute is just like him. So what does it matter which one of them teaches us? Right? I hate them both, or I like them both, like one way or the other. We become interchangeable. So what that tells me is that I can go back and forth between calling every 4x g of x and every g of x, I can call that a 4x, right? So what that means is that I could write my final answer in this form, or I can write it as f of g of x is equal to 4x plus 5. All right. I could also write it in one other way. I mean, we could simplify too if we want, but I could also write it as f of 4x is equal to g of x plus 5. Right? They all mean the same thing. I got so many ors here that I feel like it's kind of getting out of whack. All right, so this is kind of an interesting one to chew on, but symbolically, it all comes down to wash. It all makes sense. All right, so let me show you what would happen if we tried to do it on Desmos. All right, so, and then, like I said, this is where we're going to leave it tonight, so I'm not going to keep it much longer. F of x equals x plus 5. G of x is equal to 4x. All right, so these are the two given functions. So then what I could do is I could try anyway to write f of g of x. And it'll present us with a new function. It's just a question of what the equation is, or what the expression is that's equivalent to that function. I just wrote, I pretty much wrote only what they gave me. You look at this and you say, okay, they gave me this and all I did was write that. What did I accomplish? Well, it may not have given you the actual equation, the f of x or f of g of x is equal to 4x plus 5, but it gave you the graph of it, and that's worth something, right? Because if I take this, if I just write in y equals 4x plus 5, you see it gives me the exact same line. Right? It's the same thing. So it's symbolically not going to do the job for you, but it will do it graphically. And so you'd say, okay, well, that's great. What if I need to figure out something like this? What do I do? Well, the answer is you just type that in. F of g of 2, and it'll spit out the answer for you. All right, so Desmos can evaluate composite functions. All right, it'll also do it in reverse. The only thing it won't give you is the actual equation, but I would say, hopefully, that you can figure out the equation of a line, if it's a simple line, just by looking at the graph, because I would just say, all right, I got a y-intercept. Then it's just a matter of figuring out the slope, right? So change in y over change in x. So maybe I start off at this point. All right. From there, I'd have to go up 4 and right 1. So to get from this point to this point, I would have to go up 4 units and right 1 unit. And that would give me the slope. So in slope-intercept form, y equals mx plus b, the slope with the m would be 4 and the b would be 5, which is exactly what we came up with algebraically. All right, so you get this is equal to 13. So let me show you the C. We're not going to worry about the open circle notation. It kind of derails my whole strategy of doing this with Desmos. But what I can do is I can type in G of f of x. I'll turn off everything else so it doesn't get confusing or too confusing. You look at the graph, see if you can pull out the y-intercept. Right? So I got my y-intercept, the equation of a line, the slope-intercept form. Is y equals mx plus b. So they just told us indirectly, the Desmos people, they just told us that the y-intercept is 20. So I just need whatever the slope is, and I'll have my answer. All right. So I just need another clean point along the way. This looks pretty clean. -4, 4. I'll just plot it so that I don't have to hover over it. -4, 4. And just do a rise over run. All right. So 1, 2, 3, 4, 5, 6, 7, 8 units up, 2 units over. So it also just so happens to have a slope of 4. All right. If you're unsure, you type it in. Y equals 4x plus 20. Make sure it jives. It keeps it the same line. If it does, then you know you did it right. All right. So we're able to get results for composite functions without having to do the algebra. The algebra it's good to know because we're going to need it for difference quotient next class, but it's good to know that we can use the technology also. Right. So the only thing I'm going to ask you to do is take a look at number 2 for next time, and we'll go over that together. We're going to ignore number 3 because that one's just a disaster. So we're just looking at number 2. You'll try that before next class, and then we'll start off class going over that problem, and then we'll get on to the difference quotient, which is just the next step in this process. All right. So let me stop that recording.